Hi everyone, welcome to PharmaGrid. So today we are going to discuss 5 more calculations. Whatever I am presenting through my videos or through my channel, it can be lectures or mock questions or calculations. Everything will be useful for pharmacy students as well as those who are preparing for any kind of pharmacy competitive exams like DHA, MOH, HARD, KAPS or OPRA, NAPLEX, PEBC, Prometric exams, etc. Okay, so please share and support. If you find my videos useful, please like, share and support. And you can mention or you can post your valuable comments in the comment section. Thank you in advance. Okay, so let's begin with the today's first question. Data obtained from two different batches of tablets of a new hypoglycemic agent undergoing clinical trial revealed that batch 1 contains 200 mg of the drug and has an absolute bioavailability of 55%. Batch 2 contains 200 mg of the drug and related to the first batch has a bioavailability of 165%. So what is the absolute bioavailability of the second batch? Okay, so here we need to calculate the absolute bioavailability of the second batch. First we need to find out the difference between what is absolute bioavailability as well as relative bioavailability. Bioavailability, we know it is the rate and extent of drug absorption. Absolute bioavailability compares one non-intravenous route with the intravenous administration, whereas its relative bioavailability compares one non-intravenous route or formulation with another. With another in the sense, instead of using intravenous route as a reference. Okay, so instead of in absolute bioavailability, we are using intravenous route as a reference, but in relative bioavailability, we are using a non-intravenous route or formulation as a reference. Okay, so here you can see the equation for relative bioavailability, that is AUC A by dose A divided by AUC B by dose B, where A is the new formulation and B is the reference formulation. So let's see this question. Here it is given as two batches. Okay, two batches, and batch 1 contains 200 mg of drug. So for the batch 1, dose equal to 200 mg and an absolute bioavailability of 55%. Okay, bioavailability is the percentage of fraction of drug absorbed. So what will be the bioavailability? 55% means 55 by 100, that is equal to 0.55. Okay, so we know the values of AUCB as well as dose B, which is the reference formulation. Okay, so the reference formulation AUCB. AUCB is nothing but the area under the curve or the bioavailability. So that is equal to 0.55. That is 55% means 0.55. Okay, which is the bioavailability, and dose is already given. It is 200 mg. Okay, so the reference values we already know. And next, take the case of batch 2. Batch 2 contains 200 mg of drug. So we know the dose of batch 2 is also given, that is 200 mg, and related to the first batch has a bioavailability of 165%. Okay, so here relative bioavailability of the second batch is given. Okay, so relative bioavailability value is given as 165%. Okay, 165% means 165 divided by 100, that is equal to 1.65. It is a relative bioavailability. Okay, so we can substitute all the values in this particular equation, that is relative bioavailability is 1.65, and we need to calculate the AUCA or absolute bioavailability of the new formulation. Okay, that we need to be calculated, and dose is already given, which is 200 mg divided by 0.55. 0.55 is the absolute bioavailability of the reference formulation divided by 200 is the dose of the reference formulation. So substitute all these values, we will get the answer as 0.905. Multiply this value by 100, we will get it as 90.75%. Okay, so the absolute bioavailability of the second batch is 90.75%. So here the correct answer is option C. Next question. Given that ascorbic acid, it is also known as vitamin C, in an aqueous mixture decomposes by first order kinetics, and the half-life of ascorbic acid in this mixture at shelf temperature is 8 months. So what is the acceptable shelf life of ascorbic acid in aqueous solution, assuming that it is unacceptable when its initial concentration is reduced by 1 by 8? So from this question itself, it is understood that we need to calculate the shelf life of ascorbic acid. Okay, so what are the things that are given here? The drug is ascorbic acid or vitamin C. It decomposes by first order kinetics. Okay, and the half-life of this ascorbic acid is given as 8 months. Okay, so here we know that in case of first order kinetics, the equation to calculate T half or half-life is equal to 0.693 divided by K, where K is the elimination rate constant. So how to calculate K? Here T half is given as 8 months. Okay, so K will be equal to 0.693 divided by 8. Okay, half-life is equal to 8 months. So from this, K will be equal to 0.086. Okay, and T90 percentage, T90 percentage means it is the shelf life. Okay, so the equation to calculate shelf life, that is T90 percentage, is equal to 0.105 divided by K. K value we already got it here as 0.086. So substituting this value here, we will get it as 1.31. 1.31 is approximately equal to 1.5 months. So here the correct answer is option C. That is the shelf life of ascorbic acid is about 1.5 months. Next one, morphine in a 70 kilogram patient taking 20 milligram sustained release capsules twice daily was found to have a steady state concentration of 4 nanogram per ml. Assuming a bioavailability of 25%, the clearance of morphine from this patient was. So in this question, we need to calculate the clearance of morphine. And what are the data given here? Dose is given it as 20 milligram and this morphine is given twice daily. Okay, twice daily means 12-hour period. Okay, 12 hours. So, and the bioavailability is given as 25% and steady state concentration is 4 nanogram per ml. So, steady state concentration is given in nanogram per ml. It should be converted to milligram per ml. So, in order to convert this nanogram to milligram, divide this value by 1000. 4 divided by 1000, we will get it as 0.004 milligram per liter. Okay, now calculate the rate of infusion. The equation to calculate rate of infusion is dose in milligram divided by time in hour. Dose is given as 20 milligram and in the question the clue is given that this 20 milligram is given twice daily. Okay, so the time in hours will be 12 hours. So 20 divided by 12 is equal to 1.66 milligram per hour. Okay, so we calculated the rate of infusion. Why we calculate this rate of infusion? In order to substitute this value in the equation to find out the steady state concentration. CSS is the steady state concentration. So the equation to find out CSS equal to infusion rate into F divided by clearance. Okay, so in order for getting this value, we have calculated the rate of infusion here. Okay, and from this clearance can be calculated. Clearance is equal to infusion rate into F divided by CSS, where F is the bioavailable fraction. Okay, so here bioavailability is given as 25%. So what will be the bioavailable fraction? 25 divided by 100, that is equal to 0.25. And infusion rate, we already got it here as 1.66 milligram per hour. And CSS is the steady state plasma concentration, that is 0.004 milligram per liter. Substitute all these values in this equation, we got the answer as 104 liter per hour. Okay, so here the correct answer is option C, that is 104 liter per hour is the clearance of morphine. Question number 14. The elimination half-life for ranitidine is approximately 2 hours. What percentage of this drug would be eliminated from the body 4 hours after an intravenous bolus dose? Okay, so in this question, elimination half-life of ranitidine is given as 2 hours. Okay, and here we need to calculate what percentage of this ranitidine would be eliminated from the body 4 hours after an IV bolus dose. Okay, so here T half is given as 2 hours. So let's take the patient has taken 100 milligram of a drug. Okay, 100 milligram of drug. So initially there will be 100%. Okay, 100% of drug. So in the first T half means in the first 2 hours, what is T half? T half means it's the time taken for a drug to reduce into its half of its initial concentration. Okay, so initially the drug 100% will be present. Okay, so after the first T half means 2 hours. Okay, so after the first T half, it will become 50%. Okay, reduce into its half. So it will become 50%. And in the next 2 hour means in the second half life. Okay, so total will be 4 hours. Okay, so after 4 hours, the drug will reduce to 25%. Okay, 25%. So after this 4 hours, only 25% of the drug will remain in the body. So each arrow is a T half. Okay, each arrow is a T half, which means in 4 hours the drug becomes 25% of what it was. But what they have asked in the question they have asked us to find out the drug that would be eliminated from the body 4 hours after IV bolus dose. Okay, that means the remaining 75% is eliminated. How we got it as? Because only 25% will be present. Okay, only 25% will be present after 4 hours. Remaining 75% is eliminated. So here the correct answer is option D, that is 75% of the drug would be eliminated from the body 4 hours after an intravenous bolus dose. Question number 15. Dopamine 200 mg in 500 ml of normal saline at 5 microgram per kilogram per minute is ordered for a 70 kilogram patient. At what rate in ml per minute should the solution be infused to deliver the desired dose of 5 microgram per kilogram per minute? So, what all are the clues given in this question? The strength of the dopamine solution is 200 milligram in 500 ml and the dose is given as 5 microgram per kilogram per minute and the weight of the patient is 70 kilogram. Okay, so dose is given as 5 microgram per kilogram per minute and patient weight is 70 kg. Okay, so dose is equal to 70 into 5, that is equal to 350 microgram, and this microgram should be converted into milligram. That is 350 divided by 1000, that is equal to 0.35 milligram. Thus we got the dose. Now, the solution of the dopamine is available in strength of 200 milligram in 500 ml. Okay, that means 200 milligram of dopamine is present in 500 ml of the normal saline. Okay, so let X be the volume of the solution that contains 0.35 milligram. Now find out the value of X. By cross multiplying, X is equal to 0.35 milligram into 500 ml divided by 200. That is equal to 0.875, that is approximately equal to 0.88 ml per minute. Okay, so here the correct answer is option C. Okay, that is the rate of the solution should be infused to deliver the desired dose of 5 microgram per kilogram per minute is 0.88 ml per minute. So with this question we have completed today's calculation series. Thank you everyone. Thank you for watching this video. Have a nice day.